Hello, we're given a set of three problems for showcase number one. I'm going to go through problem number three. Um, this problem is as follows. So a lighthouse is built on the edge of a cliff near an ocean. Here's our lighthouse. From a boat located 200 feet from the base of the cliff, the angle of elevation to the top of the cliff is 18 degrees. And the angle of elevation to the top of the lighthouse is 28 degrees. What is the height of the lighthouse to the nearest tenth of a foot? Okay, so here's our boat. It's 200 feet from the base of the cliff. This forms a right angle, which allows us to use our SOHCAHTOA or Pythagorean theorem, depending on how the question is phrased or asked. In this case, we're going to be using SOHCAHTOA to find um, the height of the cliff and the height of the cliff and lighthouse to find the height of the lighthouse. So the first part of this question tells you about the angle of elevation. So first you kind of need to know what an angle of elevation is. An angle of elevation is the angle formed from a horizontal point to some point north of the horizon. So in this case, we've got two angles of elevation, technically three, right? Or two, really, just two here. So from the boat's sort of horizontal looking at the cliff to the top of the cliff is 18 degrees. This little smaller angle here. The total angle, 28 degrees, would be to the top of the lighthouse. Cool. So we got that out of the way. So whenever I do a problem like this, I always write SOHCAHTOA first because it's really easy to mess things up, like incredibly easy. Um, so I draw myself a little picture here, replicating what I see in the diagram, but also just kind of I don't need the picture of the lighthouse. I can just use a vertical line, and it allows me to sort of annotate it a little better with some other variables that I find helpful. So we're going to use the tangent, the trigonometric function tangent here, because we have an adjacent side of this right triangle, and we know we need the opposite side of this total right triangle as well as this smaller right triangle. So the way I look at it is we have this total height, which I'm going to call Z, and the height of the lighthouse we're going to call X, mimicking the diagram here. And then this other portion we're going to call Y. So we know that the value of X has to be some function of Z and Y. And so I wrote that down here. X is going to be Z, the total, minus Y, the part, right? So if we can find Z and we can find Y, we can find X. And so the way I did it was first I found Y. And the way I did that was the tangent of 18 degrees, the smaller angle, is equal to the opposite side divided by the adjacent side, the TOA part, right? So we'll have tangent of 18 degrees is equal to y over 200. Doing some algebra here, we can cancel out the 200 on the right side of the equation and leave it with just y, and then we have 200 tan of 18 degrees is y. I think it's easier just to leave it in this format since we need another piece rather than getting a decimal here and then a decimal here, and then you're going to have to round it and you might get thrown off because it's asking for the tenth of a foot. So try to be as precise and round at the end. So we'll just leave that as y. For the next part, we want to find what I'm calling z here, right? So very much the same. We take the tangent of 28 degrees, which is the total angle here, and we set that equal to z over 200, very similar to above. More algebra, we cancel out the 200 on the right side, and we get 200 tan 28 degrees equals z. So like I said earlier, I like to think about it like this: x equals z minus y, and then you can set up your last equation here as the value we found for z minus the value we find for y. When you put this in your calculator, you get x is equal to 41.35. And being mindful of how the question is phrased, to the nearest foot, we round that up to 41.4 feet. The units given are feet, so we want to make sure we include that. And I believe that is that. Let me see if there's anything else. Nope, I think we're good to go. Cool.